With the release of Nuendo 13, Steinberg added MPEG-H support to its flagship digital audio workstation. MPEG-H is an immersive audio format that shares many similarities with Dolby Atmos, but there are also a couple of really distinct differences. So in this video, I want to walk you through the two different workflows, one workflow according to Dolby Atmos and one workflow according to MPEG-H, so that you can make a decision what workflow is better for you. So let's get started. Similar to Dolby Atmos, MPEG-H is actually a relatively old standard, about 10 years old. Its development has been spearheaded by the Fraunhofer Institute, which was the same institute that also developed the MPEG-3 standard. The nice thing about MPEG-H is that you can download most of the tools for free. You just have to go to the Fraunhofer Institute and then essentially you can get all the tools that you need. So even if you don't have Nuendo, you can still work with MPEG-H. However, in Nuendo, that workflow is directly integrated, so you don't need any additional tools. Everything is already ready to go. One of the main differences between Dolby Atmos and MPEG-H is that MPEG-H is defined in terms of levels. So there are actually 5 different levels of MPEG-H depending on the complexity. It starts out with level number 1 and ends with level number 5. And the higher the complexity or the higher the level of MPEG-H, the more objects and the more channels you have. Currently, most implementations are limited to level 3, and that's actually going to become a bit of an issue because that is very limiting in terms of the number of objects that we can use. But before we get deeper into MPEG-H, let's first have a look at the Dolby Atmos workflow in Nuendo. Now for the video today, I'm going to work on a Mac, but everything that I'm going to show you works on Windows in exactly the same way. I'm just using a Mac for convenience purposes because that's the easier way for me to get the recording done. And with that being said, let's hop into Nuendo. Now my project today consists of 4 loops, and the loops that I'm going to use are from a sample developer called Nuendo Sounds. This is not a sponsored video, I just like to use the loops that this developer is producing, and I'm going to leave a link in the description below in case you're interested. But let's have a listen what we have here. So essentially the idea is we have a set of drums here, or a drum track. Then we have a drone. And if you're listening to this on an iPhone or on a phone, you might not hear it. It's actually a very low drone. And the idea is that we're going to use the drums and the drone as our bed, drums being in the front and the drone kind of as something that kind of looms in the background. And then we have 2 voice tracks. One is something that I call the call. And this call is then responded by a response. And the idea is that I'm going to set it up in such a way that the call comes from one side of the room and the response then from the other side of the room. So we essentially have 4 tracks. We're going to turn that into an immersive audio project. And we're going to do that in 2 different ways. First, we're going to do that as a Dolby Atmos project, and then we're going to do that as an MPEG-H project. And if you're interested only in MPEG-H, I'm going to leave a link in the description where you can jump ahead in this video in order to get directly into MPEG-H. But I invite you to watch both parts because I think it's actually quite interesting to see the differences and the similarities. So let's turn that into a Dolby Atmos project. Now the first thing that we need to do is we need to add a track that holds the Dolby Atmos renderer. And there are different ways on how you can do that. Many people put that on the master bus, especially if you have a Dolby Atmos setup with a real Dolby Atmos speaker layout. In my particular case, I'm working in stereo. So the way I usually like to do that is by adding a separate Dolby Atmos bus. So let's do that. So I'm going to add a group track here, and this group track is going to be a 7.1.4. That's sort of the maximum channel layout that we can use with the internal Dolby Atmos renderer in Nuendo. And let's call that the Atmos bus. Let's add the track. And then on the Atmos bus, what we're going to do is we're going to add an instance of the Dolby Atmos renderer. And if you search for a renderer, you already see that there are 2 different renderers now. There's a renderer for Dolby Atmos and there's a renderer for MPEG-H. We're going to work with MPEG-H later. Let's start with the Dolby Atmos one. So we're going to add the renderer for Dolby Atmos. Now, if you add the renderer for Dolby Atmos to your project, you might see an error because Dolby Atmos requires you to have a specific sample rate, a bit rate, and a specific buffer size. And if you don't have that, it will actually throw you an error and say you need to change that. So what you need to do do then is just go into your project settings and change everything accordingly. In my case, I've already set up everything, and everything is kind of working correctly. So the renderer kind of shows me everything exactly the way it's supposed to be. I'm going to leave the down mix at 7.1.4. I know that a lot of people are complaining that I never switch over to binaural, but for this project, I think it's just better because I see all the channels and all kind of the metering of all the individual channels here. So I'm going to leave that like at 7.1.4. And that's essentially the first thing that I need to do. The second thing, and I'm first going to complete all the routing. The next thing, therefore, is that I need to add a bed that is capable of handling the Dolby Atmos bed. Now, there are different ways on how you can do that. Once again, I'm going to use a 7.1.2 bed. That is the maximum layout that you can use with the internal renderer. And I'm going to then route the drums and the drone, as I said before, into that bed. But before I can do that, let's first add another group track. And this group track is going to be a 7.1.2 track. This is going to hold the Dolby Atmos bed. And let's add that, and let's maybe move that so that we have the bed organized a little bit before the bus. And then we're going to route the two tracks that we want in the bed into our bed bus. So let's do that. So the first thing I'm going to do is I'm going to route the drum track into the Dolby Atmos bed. And I'm going to leave the drums at the left and right speaker. I think that's perfectly fine. And as I said before, I want the drone to be in the back. So I'm going to first of all route that into the Atmos bed, and then I'm going to simply move it back, maybe something like that, and maybe move it up a little. So that we have a little bit of action in the height speakers of the Dolby Atmos bed. So now I have everything set up. So the next thing is I need to change the project settings in Nuendo in order to work with the Dolby Atmos renderer. So I'm going to go into the project settings, and in the project settings under ADM authoring, I need to set the type of immersive audio format that I have. Currently nothing is set. So the next thing I need to do is I need to switch that over to Dolby Atmos. Now you have in Nuendo two options. Obviously you can work with the external Dolby Atmos renderer or the internal Dolby Atmos renderer. Here we're going to choose the internal Dolby Atmos renderer. You could go through the setup assistant that allows you to kind of let Nuendo do all the work, but it's actually not that difficult to do that manually. So we're going to do that manually here. So the first thing I need to do is I need to add a bed, and the bed that I'm going to add is going to be the Dolby Atmos bed. And that essentially kind of shows me then that this bed is routed into channels or objects, IDs 1 to 10. Those are the first 10 channels in the Dolby Atmos renderer. And then we're going to add two additional objects for the call and response tracks. Those going to be stereo objects. So technically, those are actually 4 objects, kind of 2 per track. But let's add 2. And then essentially we need to define the source track. Now, if I try to select them now, I can't. I currently only see the drone and the drums, and the reason for that is that the ADM authoring window only sees those tracks if those tracks have the correct panner on their tracks, and this is currently not the case because we set everything up manually, and that means that we have the stereo panner on the track. Now, the easiest way to get the correct panner is simply to route those objects into either the bed or the bus. I'm going to route them into the bed, so let's just route from the stereo out into the bed. The audio itself is actually not going to reach the bed through the routing, through the Nuendo routing. It's actually going to reach it through the Dolby Atmos routing, but it helps us to set up the correct panner. So now we actually see that we have this essentially the multi-panner here, and I'm going to do the same thing for the second for the response here, and let's move that over to the Dolby Atmos bed. And now if I go back into the project settings and go into ADM authoring, I can now select the objects. So here we have the call and the response. So let's lose the first one, the call, the second one, the response. And they come in at the object IDs 11, 12, 13, and 14. And at that point, I should already hear my Dolby Atmos file. So let's open up the Dolby Atmos renderer so that we see what is going on in the renderer. And as you can see, we have the bed coming in at the first 10 channels. There's nothing in the center channel, and there's also nothing in the LFE, but everything else is is getting information, and then we have the two object pairs, 1112, which was the call, and the 1314, which was the response. So currently everything is located at left and right front speaker, and that's a little boring. So what I'm going to do now is, and as I said before, I want to have the call on the left side and the response on the right side. So let's just do that. Let me go back into the panel. And for the call, what I'm going to do is I'm going to move that over. So let me just rotate it, maybe something like this, and then move it to the side. It's a little much. Let's make it a little bit more like that. And then let's do the same thing, but on the other side for the response. And so let's something like that. And then essentially, yeah, that's good enough. And you can see now that these are also on the Dolby Atmos renderer. I have the location here. Let's maybe do one more thing. Let's change the size of the objects. Let's make them a little larger, so that we're also kind of playing around with the size a little. Let's kind of also change that here. Now I could obviously also change the head, but I'm just going to leave that at ear level, and that's perfectly fine for this particular project. So let's play that again. So now I have the call on one side, and then essentially the response is going to come in on the other side. And for those of you who want to hear that in binaural, let's just quickly switch over to binaural. Let's hear that one more time. Switch that back to 7.4. Now, if you switch it to 7.1.4, obviously, then Nuendo is doing the down mixing to stereo. So essentially, you get a stereo signal, not a binaural signal. But you know, kind of, because, as I said in many other videos, because most of my viewers are actually listening to my videos not through headphones, I usually kind of prefer that in stereo. But you know, kind of, binaural actually sounded quite nice. So now, obviously, the next thing we want to do is we want to export everything. And in order to export that, what we have to do is we have to go into the project settings, and under ADM authoring, here we have the export button. Now, in order to be able to export, we actually need to select a range. I already have a range selected here because I was looping these loops. But if you don't have that, you need to set that up. Otherwise, the Dolby Atmos renderer doesn't really know where the beginning and where the end of your audio is. But once we've set that up, all we really need to do is we need to export that. So we press the export button, and that will then give me the option to give it a name. Let's call that Test Atmos. Because we are really testing the Atmos version here. And let's say save. I already have that. I already did that in advance once, but let's overwrite that. And then essentially I have everything exported. So the last thing I need to do now is to play back that Dolby Atmos master file in order to make sure that everything is exported correctly. This is important, obviously, before you upload it to a streaming service, for example. Now, it is important to know that you cannot simply play back that master file on any audio player. It needs to be a special audio player that can actually play back master files. Now, the easiest way to do that is with the external Dolby Atmos renderer, and you can actually use the Windows version as well as the Mac version for that purpose. And as an added bonus, if you're using the external Dolby Atmos renderer, you can also use that in order to export an MP4 quality control deliverable that you can then play back on any audio player that can play back audio. So here we have the Dolby Atmos renderer. So the thing I need to do now is to simply open up that file. And what I'm going to do is I'm going to open up that master file. And that master file was the Test Atmos master file. So let's open that up. And once I've opened it up, I see the master file here. And I should be able to simply play that. And let's listen what we have. And I see the objects here. And that worked perfectly. So now I have the Dolby Atmos master file completed. Once again, if I want to, I can, through the Dolby Atmos renderer now, for example, export the audio into MPEG-4 format, and that would then be a format that I can play back on any audio player. And that's essentially the Dolby Atmos workflow in Nuendo. So let's start over again and let's do the same thing for MPEG-H. So I'm now back to the original project and let's do the same thing for MPEG-H. Now the start is fairly similar to the start with Dolby Atmos. We also need a track that holds the renderer for MPEG-H. And we can also, as we did with Dolby Atmos, do that either by using the master bus, or we can create a separate bus. And as I did with Dolby Atmos, I'm also going to create a separate bus here. So let's do that. So I'm going to add a group track. Now, MPEG-H is a little bit more flexible in terms of the channel layouts that you can use, but I'm going to use a 7.1.4 layout here for the bus. And let's call that MPEG-H bus. And let's add that track. Now, the next thing I need to do is, similar to the Dolby Atmos workflow, I need to add the renderer, but this time we're going to add the MPEG-H renderer. And so let's do that. Let's go into the settings and let's add the MPEG-H renderer. Now, important note, if you have downloaded the Fraunhofer tools, then you will actually have two renderer in your plugin collection. One is the renderer that comes with Nuendo, which is the one that's called renderer for MPEG-H. And then you have the tool that actually comes with the toolset from the Fraunhofer Institute, which is called MPEG-H Author and Plugin. And it's important to use the renderer for MPEG-H, the internal one. They look fairly similar. Let me just show that for a second. So here we have the, and currently it's fairly empty because we haven't really done anything yet. But this is the internal renderer, the internal Dolby, the internal MPEG-H renderer. And let's just for comparison also load up the MPEG-H Author and Plugin. And you can essentially see that it looks fairly similar. There are a couple of differences in the Fraunhofer version. Obviously, there's the branding here. And then in the authoring plugin, what you have is you have these additional options here for adding channels and adding objects. And that is because in the authoring plugin, you actually do that through the plugin itself. Whereas in the Nuendo integrated version, we are going to do that through our menus here. So you only see these switch groups here. And I'm going to come back to the switch groups a little bit later. But make sure that you are using the correct one if you have both. So let me just delete that one again, because once again, we only need the internal MPEG-H renderer. And then we need to add a bed. I'm going to do the same thing that I did for Dolby Atmos. So I'm going to use the drums and the drone as something that goes into the bed. And then I'm going to use the call and response tracks as two objects, which we essentially, once again, will end up being four objects here. Now, MPEG-H has one difference to Dolby Atmos, and that is that it allows multiple beds. So we could actually use separate beds for the drums and the drone, and that can come in handy at certain situations. However, the disadvantage is that because of the limitations of MPEG-H, we actually don't really have a lot of tracks or object tracks available to us. The current implementation is limited to level 3, MPEG-H level 3, and that means that we have a total of 16 tracks available to us. And that's actually going to become a little bit of an issue in terms of limitations. In the future, if they implement a higher level of MPEG-H, that actually might be comparable to what you can do with Dolby Atmos. But at the moment, we are somewhat limited, and we can only use a couple of objects here. But it's essentially fine for this presentation. So I'm going to use one bed track once again, because I don't really have a lot of tracks that I can use, a lot of channels that I can use. So if I have one, I'm already kind of maxing out what you can do with it. So let's just do that. Now I'm going to add one bed track, and in MPEG-H, you once again have more options in terms of what channel layout you want to use. And what I'm going to do is I'm actually going to use a fully immersive channel layout. In Dolby Atmos, you're limited to 7.1.2, essentially with two overhead speakers, and that is not really fully immersive. In MPEG-H, what we can do, for example, is we can use and let me just go down here. I'm going to use a 5.1.4 layout, and MPEG-H will be able to actually do that. So let's call that MPEG-H bed, MPEG-H bed. Let's add that track, and then let's do the same thing that we did with the Dolby Atmos. Let me just rearrange that. Okay, here we are. And then we need to do the same things that we did with Dolby Atmos. We need to start the routing. Once again, we are doing the routing of the drums and the drone into the bed. So let's just do that. We're going to add that, and we're going to route it into the bed. I'm going to leave for the drums. They located in left and right channels. That's fine. And then we're going to do the same thing for the bed. For the drone. And the drone is also going to be routed into the bed. And here I'm going to do the same thing that I did with in the Dolby Atmos version of this project, and that was that I'm going to simply move the drone into the back and slightly above. Now, one thing that is different in MPEG-H is that MPEG-H objects can actually live below the listener level. That's actually one of the things where MPEG-H has a certain advantage over Dolby Atmos, but for the bed, once again, because we're using a regular channel layout, we are limited to the listener position here. So we're going to have it just a little bit above the listener, but we cannot really go below it. Okay, so I've now prepared everything, and the next step would be to tell Nuendo that we want to use MPEG-H. So we're going to do the same thing that we did with Dolby Atmos. We're going to go into the project settings. We're going to go into ADM authoring, and in ADM authoring, this time we're not going to select Dolby Atmos. We're going to select MPEG-H. And that will essentially, first of all, throw me a warning. And that warning is that I need to select the 3-layer 3D pan mode. MPEG-H uses a different pan mode than Dolby Atmos does, so we need to go into the project settings in order to change that. It's going to remind me that I have to do that. So let's just press OK here. And before I forget, let's go into the project settings, project setup. And in the project setup here, I have the 3D pan mode. And I can essentially then select the 3-layer, and that will make sure that everything works correctly. And then I'm going to do the same things that I did for Dolby Atmos. Once again, I could use the setup assistant. I'm not going to do that because it's, once again, very simple to do. So I'm going to add a bed. And that bed that I'm going to do is going to be the MPEG-H bed. And as I can see, it's now going to be routed into object IDs 1 to 10 in the very same way we had with Dolby Atmos. And then I'm going to add 2 objects. And very similar to what I had with Dolby Atmos, I'm not going to see these objects until I actually have changed the panner on those tracks. So let me just do the same thing that we also did for Dolby Atmos, and let me just route these 2 object tracks into the bed. Once again, it doesn't really make any difference. I could also route it into the bus, and but essentially I'm going to route it into the bed. And once I've done that, I can go back into the project settings under ADM authoring, and I now should see these call and response tracks. So we're going to have the call here, and then we're going to have the response. And similar to Dolby Atmos, they're coming in at 11, 12, 13, and 14. Now here you already see a little bit of an issue because we're limited to 16 tracks, and that essentially means with these 3 tracks that I have here, I've already maxed out pretty much what I can do with the MPEG-H renderer at level 3. It would be really nice if Nuendo would allow higher levels of MPEG-H, but my understanding is that this isn't really implemented also in the Fraunhofer tools. They'll also kind of limit to level 3. Now, they do have experimental level 4 support, which essentially would double the number of channels that you could use. So you could have 32 output channels, but that is, in my testing, it didn't really work particularly well. And there's also not a lot of support for higher levels than level 3. So you are kind of limited to level 3. So we're going to talk about that a little bit later, what that means in terms of applicability. Can you actually use that if you can only use that few tracks? But you know, kind of there are certain situations where it's still very, very useful to do that way. So I've now done that, and then the next thing I'm going to do is, and I'm going to do that before I go into the MPEG-H render, because there are a couple of things I need to set up there. Let me first also do the panning. So we had the call. The call was on the left side. And we also had the object size a little larger. Let's do the same thing that we did for the Dolby Atmos version of this, and let's kind of also move that around, and let's move that to the right. Doesn't really make a whole lot of difference. It's just for demonstration purposes. And then we need to route everything into the MPEG-H renderer. And here is where a couple of differences are. So let's open up the MPEG-H bus and let's go into the MPEG-H renderer. And the first thing that you see if you open it up, it actually kind of shows you the errors here. And by the way, you're also going to see these errors if your bit rate or sample rate and your buffer size is not correct. Similar to Dolby Atmos, MPEG-H also requires a certain buffer size and a certain sample rate. They are unfortunately slightly different, so you might run into issues where it works for Dolby Atmos, but it doesn't work for MPEG-H. However, if you set everything, I think, to 1024 in terms of buffer size, and then 48 kilohertz in terms of sample rate, you should be fine. Now, if I click on the error button, I essentially see that the scene currently contains no preset, and that essentially is because in MPEG-H, I first need to define presets. And I actually can have multiple presets, meaning that the scene that I have, or the way these individual tracks are laid out, can have different arrangements, and I can work with different arrangements. And so the first thing I need to do is I need to add a preset here, and I'm going to add the preset, and I'm going to call that test. Doesn't really make a whole lot of difference. I can give it a count, but that doesn't really make a lot of difference either. And then I essentially need to tell what of the components that are currently routed into the MPEG-H renderer are part of that particular preset, and I'm simply going to add all. And all essentially means my components here. I have and I actually can give them names. So this would be the bed, for example. And I can also give them essentially names, the four objects that I have, the call. Once again, there were two stereo tracks that essentially ended up being four individual objects. So we have like the right side of the call, the left side of the call, the right side of the response, and the left side of the response. I'm just going to leave that like that. That's perfectly fine. And now you might notice that you have these abilities here or these things here that you can actually change. And for many of the controls here, you can't really kind of do much. And the reason for that is because most of it is controlled through the panning device in Nuendo. If you would work with the MPEG-H authoring plugin, you would actually kind of do everything within that plugin. But in Nuendo, you're actually kind of using the panning devices for most of the work in terms of panning and these types of things. Now, a couple of things that I should point out. First of all, one thing that you can do is you can also add so-called switch groups. And this is actually where MPEG-H gets really interesting. A switch group is essentially a group of components that is set up in such a way that the listener can actually switch between them. And the typical example that is always brought up is if you have a movie, for example, and you have different language files, a switch group would be used in order to allow the listener to switch between the different languages. So you would essentially create a switch group with the different language tracks, and then essentially if somebody listens to your MPEG-H audio, they can then switch between those language files. This is where a switch group is used. And there are also a couple of other options in terms of interaction. So, for example, you can, in the presets, you can say how the user is interacting with your individual components in that particular preset. So MPEG-H allows a lot of options in terms of interactivity, where the listener can actually influence actively what he or she is hearing, whereas Dolby Atmos is a lot more static. So once you've set up your Dolby Atmos project, everything is exactly in the same way for every listener. Here in MPEG-H, you actually have some flexibility, and you can give some control to the listener in terms of what they can do with the audio. Now here we're going to leave everything the way it is. And the final thing is here in the monitoring setup, we can, similar to the Dolby Atmos renderer, select in what layout we are monitoring. And let me just switch that over. We are on a 7.1.4 track. So let me just switch that over to 7.1.4, and that will essentially make sure that everything is that I hear in 7.1.4. So let me just play the audio because now everything should be set up correctly. So I have the 5.1.4 bed that holds the drum track and the drone track, and then I have the call and response, which are the four objects. Essentially, the two objects on the left are the call, the two objects on the right are the response. And let's play the audio. And as you can hear, it actually works quite fine. Now, one thing that you might have noticed, and that is a question that I get quite often, is that if I play the audio file, I'm not really seeing the meters here for the objects. And the reason for that is because in Dolby Atmos as well as in MPEG-H, the audio is not routed through the traditional routing in Nuendo. What is really done is it is routed from the panner directly into the renderer. So if you want to actually see the metering, what you need to do is you need to kind of select, you need to go into the global meter settings, and in the global meter settings, you need to change that from post panner to post fader. And once I've set that to post fader, you will actually see the audio as it goes into the Dolby Atmos, the MPEG-H panner in this particular case. And as a bonus, if you do it that way, you also see the individual tracks that are coming out of the MPEG-H renderer. Okay, so the last thing now is to also export that, and the export works very, very similar. Now, because the implementation in Nuendo is based on the actual authoring plugin, you actually have the export button here. Be aware, though, that if you kind of do the export directly through the export button, it will actually ask you to set an in point and an out point, so it's a little bit more complicated. The easier way to do that is to go through the same way, or kind of use the same thing that we did in Dolby Atmos, to go into the ADM authoring settings, and in the ADM authoring settings, let me close the MPEG-H renderer here. I have the export ADM file, and if I kind of click on that, I will once again go back into the MPEG-H renderer, but everything will kind of be set up in exactly the way I need it to. So let's just do that here, and let's click the export button here. Now I have a couple of different options on what I can do or what I can export, and in MPEG-H you can either export that as a BWF ADM file, which is similar to the Dolby Atmos master file. Be aware that those are different standards, so they are not interchangeable, so you cannot use one for the other. They are really different. But in MPEG-H, what people usually use is an MPF file, which is sort of an MPEG-H production format file. So we are going to leave it like that, and let's save that as, let me save that on the desktop, and let's call that test MPEG-H, and let's save that. And then essentially, once I've kind of set up everything I need to do, I can also choose to select to also export the channel mixes and all kinds of things. And then what I'm going to do is I'm going to simply set start, and once I do start, it will do the MPEG-H processing and will export everything correctly, and if everything worked correctly, I will actually get a success message. And with that, essentially, kind of the last thing I need to do is need to simply check if the MPEG-H export actually was successful. And for that purpose, we can use the tools that Fraunhofer provides. If you go to the Fraunhofer Science, once again, link in the description below, you can download all the tools, and a couple of those tools are really useful. You have, first of all, an info tool where you can simply drop your MPEG-H file, and it will tell you the individual components and how that MPEG-H file is constructed. You have an MPEG-H player that allows you to play MPEG-H files. And then you also have a muxer that allows you to combine video with MPEG-H so that it can create MPEG-H video. So let's do that. So let's open up our MPEG-H player and see if that audio file actually kind of reached the desktop in the way it's supposed to be. So here I have the MPEG-H production format player. So all I really need to do now is I need to drop the file that I just created, the MPEG-H file, and drop that into the player. So let's do that. This was this file here, and I'm going to drop that in here. It's open it up, and then let's play it and see if everything has been exported correctly. And here you also see a little bit of the issue, because we are limited to a level 3. Essentially, we're limited to 16 channels, and channel number 16 actually holds the metadata. So it's actually only 15 channels that we have. So with the 2 tracks that we had that created the 4 MPEG-H objects, Together with the 5.1.4 bed, we already maxed out the abilities. There's only the option for one additional mono object that we could add, and then essentially the level would be reached, and we can't really do any more than that. Now, if you're reaching the limits of level 3 MPEG-H in Nuendo will actually give you a warning and will tell you that you have now exceeded the limits of level 3, and then you have the option to enable experimental level 4 support. However, in my experience, that didn't really work particularly well. So for most of the situations, you will be limited to level 3. And that means that you don't really have a lot of options for objects. So for music production, I think that is probably a little bit too limited. I would like to have a little bit more options in terms of number of objects that I can use. However, in certain situations, that might not make a big difference. So if you're working with movies or video, for example, the fact that you can use MPEG-H in order to enable some interaction between the viewer and the audio is actually beneficial. So if you have, once again, multiple language files, for example, that is definitely a big advantage. However, for music production, I think it's not ready for that. It really needs more possibilities in terms of the number of objects that we can use. So in conclusion, I think that MPEG-H is a really interesting technology. However, especially for music production, it is still very, very limited. I think that level 3 is simply not enough. We would need to have at least level 4, ideally level 5 support that essentially would give us 64 output channels. I think that would be more than enough. However, the 16 channels are really very limiting. And in addition to that, it's also not really something that is supported by streaming services at that point. So if you're in music production, then Dolby Atmos is your best bet. And MPEG-H is an interesting thing to keep an eye on, but it's not necessarily something that I would use at that point. However, there are a couple of advantages that MPEG-H really has. First of all, it is an open access technology. So if you're working with Reaper, for example, and you want to just have a quick view on how to work with immersive audio in a way that doesn't break the bank, you can simply go to the Fraunhofer site, download all the tools, and then you can create object-oriented or object-based immersive audio without anything that you have to pay for. And that is a big advantage. And then we have greater flexibility in terms of beds. We can have multiple beds. We have multiple channel layouts. The specifications also allow us to use ambisonics. However, I have not seen that implemented yet. So in theory, the technology should be able to handle ambisonics beds, for example. But once again, I haven't seen that in any implementation. And then it is something that is probably more suitable for video applications because of the switch groups and the added interactivity that you have, which I think is really beneficial when it comes to video because it allows you to create some form of interaction that the viewer can have with the audio that you're creating for your video production. But this is really everything I wanted to say today. Thanks again for watching my videos. If you have any questions or comments, please use the comment section below or join our Discord community. Invite link is in the description below. And with that being said, see you at the next video.